everybody. My name is Darren Riley. I am the HVAC product sales manager here at IAC Acoustics. And today we're going to have a little bit of a webinar and a training session with our Snap tool mainly on HVAC noise control products and system. IAC Acoustics is a Catalyst Acoustics Group company, again, CAG. CAG is a parent company of an elite group of acoustic, seismic, vibration, and noise control companies that together we offer the broadest portfolio of noise control solutions in the market today. Again, myself, Darren Riley, I've been here with IAC Acoustics now. I've been doing HVAC here for about 17 plus years in this industry. Nathan Mahallison, he is our IAC HVAC project manager and engineer, and he has been in this industry for over 12 plus years here as well. Today we're going to go over these presentation topics: duct silencers and acoustic louver basics, HVAC duct silencer products, our louver products, our online tools, show you some application and installations, show the duct lag and quiet vent product brochures. And again, if there is any time for questions and answers, we could do that. Most likely if we won't, so I apologize for that. But if you do have anything there, just simply email me. We can actually have a one-on-one conversation. What makes IAC superior to the competition? We are strategically located within our manufacturing facilities in the major markets. So we are on the East Coast, Midwest, South, East, and on the West Coast. One of the biggest things is our industry-leading quick ship program. We have a 5-day and a 10-day lead time quick ship program. And this is for all of IAC's full product line. Again, all of our HVAC type products. Typically, mainly, we like to keep it with galvanized. If you do have a onesie twosie with, say, 304 stainless steel, 316, or say aluminum, we can look at doing accelerated deliveries for those as well. All of our products are 100% successfully made and fed in the U.S. businesses and economies, and we have a broad range of union affiliations. Some more is reliability and consistency. IAC's products are fabricated with the same designs, drawings, materials, and tooling that were used in the Bronx for decades. We're talking 73 plus years now. We also focus on solutions developed from standard models and configurations with our consultants, engineers, contractors, and owners. So again, 100% transparent. They know what they're getting every time. IAC acts to serve both the construction markets and the acoustical engineering community. And again, some of the broadest product portfolio in the market today, including the full range of sound attenuators, multiple acoustic louver profiles, packless type silencers, our elbows, pipe and duct lag material and product, transfer vent, quiet vent silencers, and now our heavy gauge fully welded silencers. Our virtual tool. IAC has came out with this around about 4 or 5 years ago. It has just completely accelerated within the market. It gives you quick select menu for prompt processing of product selections, flexibility to compare our products with other known alternatives, customizable options, and expedited results. You can save and revisit these projects at any given time, make any corrections that you need. And again, this is compatible with smartphone and tablet. Something I haven't added to this yet is you can be 38,000 feet in the air and working on this thing as well. It is amazing. The tool that we're going to go over here today too then is our IAC Snap tool. This provides basic silencer application assistance for airborne duct noise for source to interior or exterior projects. So again, you can literally do a nice little silencer assessment, and we will go over this here shortly. Duct silencer and louver operating principles. We'll start off here with duct silencer. So as you can see, it has the bell mouth entry. We have the evase exit, the air passage, perforated baffle cover, flanges, sound absorptive fill, the shell, you name it. This is a very good picture of what an interior silencer looks like. Ventilation and air movement systems, they utilize ductwork to route air from location to location. Noise can easily be transmitted along with the airflow. So air makes noise. Silencers and louvers then operate by absorbing sound as it passes through the silencer or louver while imposing only a minimum restriction on the airflow. Now, this is a little bit different picture than what you just saw. This one here is IAC's famous bell mouth entrance and exit type silencer. 99% of our silencers are going to have this look on both sides. So the left side versus the right side, it's the same. This here, it minimizes turbulence, pressure drop, and self noise. The straight air through passages are designed for maximum air handling, again with minimum pressure drop. Acoustic baffles with this type of design are for maximum attenuation at low frequencies, which is roughly the toughest job to attenuate. What we're going to go over today are some, performance considerations. You might already know these, but again, it'll give you a nice refresher for some basics. First, we'll start off with face area. Face area and face velocity. Face area is width times height. Take that in square inches and convert that to square feet. Face velocity then is take the CFM of what the piece of equipment is producing, say at 4,000 CFM, divide that by your then face area, 4 square feet. You now have 1,000 feet per minute. Another performance consideration is the aerodynamic airflow resistance. This is a unit of pressure at a given face velocity in H2O. And you see the Bernoulli equation. If you want to go over this, we can at some time. Contact me. I will be glad to go over this with you on one-on-one basis. We are getting ready to go through a whole round robin of testing where you are going to see online and in video of how a pitot tube is installed on either side of the silencer, air flowing into the ductwork through the silencer, through both areas of the pitot tube, and how this is actually measured in the manometer. It is measured with water inside that area where you see red. The difference then is the actual pressure drop. We have some really unique tables within our catalog, so take a look at that at any given time. We have 3 foot, 5 foot, 7 foot, or 10 foot. What is really unique though, again, with our virtual tool, not the snap tool, but the virtual tool, you can plug in any width of your and height of your desire from starting at 6 inches going on up. And you can plug in any length up to 120 inches and it will give you the pressure drop. Now, another performance consideration is this. Next, we have the percent of open area. This is calculated to AP divided by width. Now, note here that half the gaps and half baffle thicknesses are H and D respectively, and performance is only based on these parameters. So, take a look at the single silencer on the left, then look at the 3 on the right, having different configurations. All have the same acoustical performance to that of the one on the left, basically assuming that the dimensions for H and D and L are the same. So the number of baffles and air gaps only affects the flow area, as does the height and or the span of the baffle. Having more baffle arrangements within the silencer, you will then have more flow area. You'll also then have lower air gap velocity, resulting in lower pressure loss. Here is a really good example at flow directions. At the top, we have positive flow, also known as exhaust or supply. At the bottom, you see negative flow, commonly also known as inlet and or return air flow. Now, the difference between the two is this, is that with the supply airflow forward, this is a condition that exists when airborne sound and airflow are moving in the same direction. Under forward flow conditions, high frequency sound is refracted into the duct silencer walls. With reverse, this is a condition that exists when sound waves and airflow are traveling in the opposite direction. Case in point, being pulled back through. Under reverse flow conditions, sound is refracted away from the walls, but yet toward the center of the duct silencer. The acoustical performance dynamic insertion loss, DIL. Here's at the top of that, you can see the nice little equation. This is shown in forward flow, again, the air flowing in the same direction as the propitiation of sound. So for this type of loss, This would then be the difference between the sound power or intensity levels measured in and at the same point of the ductwork with the pitot tube before and after the insertion of the silencer. As well as the pressure drop, we also have tables that show acoustical dynamic insertion loss performance. Again, through the virtual tool, you can do odd sizes and odd lengths. Now, some sources of self noise. This becomes some considerations that need to be taken into effect. So there are a couple different things with silencers. Dynamic insertion loss. You want to control air and noise. And at the same time, silencer could potentially put noise back in the system. So with insertion loss, you think, all right, loss is a number, each in the 8 octave bands. So the higher the number of the dynamic insertion loss of those 8 octave bands that could be, the more loss you're pulling out of the system. So in essence, you're lowering down the decibels of the fan or chiller or cooling tower, again, whatever piece of equipment you're lowering that down. So again, you're making that piece of equipment become quieter. You're also making the airflow quieter because you're controlling air movement. Now, at the top left, you can see some self noise can be caused with the interaction with the perforating material within the silencer. Typically, this is, you're going to hear some self noise if this is completely installed right to the fan or the piece of equipment. Ultimately, with a higher rated pressure system, say 10, 12, 20, 30, 40,000 CFM, you're flowing air out of 100% area, say 40 by 40, through and into automatically right away into a silencer. That could be 40% free open area. So that could cause some whistling effect. At the top right, you see some self noise that can be generated right at the entrance of the silencer. With our bell mouth entrance and exit though, our silencers act better. It helps to separate the air. And then at the bottom left, right there at the bottom, you can see the discharge separation and turbulence is very, very minimal. So at this here, you can see that some noise can be generated at the discharge of a silencer, but again, with the bell mouth entrance and exit, air comes in equally and exits equally. Here's just, again, another pictorial of self-generated sound coming from the fan on the top for forward flow. You can kind of see where noise can be an issue. At the same time, down at the bottom, you see self-generated sound. Again, air pulling in the noise going in reverse. And again, you can see where the noise is there in between the silencer and the fan instead of after the fan. Another table again is the self noise levels. We like to be able to showcase this and show this. So if there's any given time at a face velocity feet per minute, I have some really neat tables that help you. Let's say you have 720 or a negative 860. Let me know. I can send you some tables. We have some really nice tables that we can share. That way it gives you the ability to actually see this firsthand. At the same time, going into the virtual tool, you can plug in the width by height by length, plug in the CFM, pick a silencer. It gives you the dynamic insertion loss and it gives you the self noise levels. Moving on, product range. All of IAC silencers and louvers were developed in response to the specific requirements from acoustical consultants, engineers, building owners, and contractors. Everything has been tested for performance, that they provide the most economical choices for solving the wide variety of noise control problems encountered in HVAC engineering today. Going through our silencers here, we have the Quiet Duct Commercial Series, also known as Q-Duct. So that is kind of a name, a term that you can kind of memorize, Q-Duct. We have our standard silencers with fiberglass infill. We then have our Quiet Duct Clean Flow Series, H hospital grade, known as the H before the nomenclatures. And then we have the Quiet Duct Ultra Green, commonly known as UG type. Same thing, but instead of fiberglass, this has 100% cotton infill. It is dipped in an antifungal, anti-mildew solution. And these are great for 100% environmentally friendly attenuation solutions, uses basically, again, recycled fill material, delivers performance that meets and or exceeds sometimes that of the standard fiberglass quiet duct silencer. Here is a great pictorial of our hospital grade film liner. I like to go this because I like to be able to showcase a little bit what IAC does different than what our competition does. A few things is that you can see the very first thing is you have the bell mouth entrance and exit. So again, the curved nose pieces are solid. You have the perforated material. Behind that perforated material, you have a track wire mesh to the baffle. This is really cool because it separates the heat sealed polyethylene bag that encases the fiberglass material. So that way this does not stick to the perforated material. A lot of the people do not do this. This enhances our performance of our hospital grade silencer, number one. And number two is the heat sealed bag totally encapsulates the fiberglass material. So this keeps any type of fiberglass material being emitted into the system. This is very critical for hospital grade type silencers. The really cool thing too about our heat sealed polyethylene bag is that if you look in again, for leftovers, when you're cooking and you have leftover food, you wrap it with cellophane wrap. You look at that, that is a solid. Our heat sealed polyethylene bag is very, 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 very tiny perforated. So it allows it to breathe air movement in and through the fiberglass, back out like it should, and on. So again, we have better control and better performance with our hospital grade type liners. We have what is becoming ever so popular now, our quiet duct elbow silencers. And down on the bottom left, you can see how we actually build our elbow silencers. The turning vanes are actually part of the actual inner baffles. This helps out with airflow movement. At the same time, it helps keep pressure drop low. We also have our Ultra Pals packless silencers, standard rectangular type is the XM, XL, KL, and KM. Again, there is no perforated. Okay, behind this is, instead of a standard perforated material, which is 23 holes per every square inch, it is now 86 holes for every square inch. So again, smaller, finer holes per square inch. There is no infill material whatsoever. Again, packless silencers have no fiberglass, have no cotton, and they do not have any type of mylar liner. So packless silencers, again, have no infill whatsoever, but it is a perforated material and the baffle thicknesses and open air passages that create the actual insertion loss. We also have our TXS, TXL, and TXLB, which is the one to the right, the TXLB. These are our tubular packless silencers. These can range anywhere from 6 inches on up to 24 inches in diameter. We have our quiet duct conduit flow series, and then our D-duct diffusers. The D-duct diffusers are typically used with axial type fans. So these are axial type silencers. They are placed on the inlet and outlet of the axial fan. What this does is I've kind of nicknamed this for myself and for others. It is a dump loss silencer. You get a negative regain. So zero added pressure drop, number one. Number two is it is a negative regain. So what I mean by that is that the bullet inside the D-duct diffuser matches the actual bullet or hub of the fan. Air flows proportionally right over top of both. You are able to have some insertion loss. At the same time, no pressure drop being added back to the system. The coolest thing about this is that if the fan is operating, say, at 5 static pressure and you really need to knock this sucker down, we can knock it down to about a 1/2 inch static pressure. So get with me on this. If there's any need for the D-duct diffusers, we like to do those in-house for engineering purposes. That way to make sure that these things are designed proportionally. We have our quiet duct ultra low silencers. These actually enhance with the 31.5 octave band. And then we have our quiet duct ultra zero added pressure drop with the wings on the outside. These are the baffles on the outside. There are no middle inner baffles. These are kind of stuck right now with a open width at 6, 9, or 12 inches. You can take this at any height that you want to, but for right now, we are looking at adding on a larger line of this as well. Moving on to louvers. Again, we have our louver catalog, which can be downloaded right off our website. This is a great way to kind of showcase a little bit of what we can do here as well. And our louver operating principles. Our louvers are multi-purpose, meaning permitting airflow while shielding the environment from unwanted noise. They can be reverse and or forward flow. You can see the sound source is behind it inside. And I like to hit on this because a lot of people like to do percent of free open area first versus noise. Taking care of noise, taking care of performance. I say do performance first. Again, at the intake and discharge of the louver, you have 100% free area. So 10 foot by 10 foot opening. At the closest point though on louvers, whether it's ours or anybody else's, you're going to be 18, 20, maybe 30% free open area because the diffuser effect on the discharge side, you get a pressure regain. And the louver performs much better than 20% free open area. Based on our testing and analysis with the louver testing criteria, the Model R louver pressure drop performance is equivalent to a straight bladed parallel louver with 46% free open area. Model LP is roughly 50%. So the pressure drop listed in our catalog is based on face velocity across the entire face of the louver, not just the free area. For example, if you had a 10 foot by 10 foot rough opening at 50,000 CFM, your face velocity would be 500 feet per minute. This would yield a pressure drop of 0.27 with our Model R louver. This is great. Some other manufacturers rate their pressure drop performance based on air velocity through the free area, whereas we rate based on air velocity across the rough opening, in which case the free area is not required for the calculation pressure drop. If you want to go over this in more detail, contact me. I would be glad to go over this with you. But when you're designing louvers, design louvers to performance first. Percent of free open area is what it is. I've gone through this many times, and a 10 foot opening, if you want a 50% free open area, it might have to actually increase to say 14 by 16 feet. The hole might already be open there, only at 10 foot by 10 foot, and you cannot increase it. That then becomes a problem. So again, if you want to go this later on at any given time, contact me. I would gladly go this with you in more detail. We can do louvers in many different shapes and sizes, from screens and ventilation openings to integrated doors. Here is a nice screen around the Children's Hospital of New Jersey. And we can do turnkey, meaning we can provide steel post. We can also provide wind analysis as well. Here's one on grade. And again, you can kind of see the steel post a little bit right in through here. So if there is any given need, we can provide this as a complete turnkey. This is a really cool page too, because this shows you how to specify our acoustic louvers. We have this for our noise shield and our slim shield louvers. So download this, take a look at that, read through it. Any questions, let me know. We have our Model R, which is a regular type louver, Model 2R, which is, again, Model R is 12 inches, Model 2R is 24 inches, two of them back to back, creating a chevron look. We have our Model LP, which is low pressure drop, again, 12 inches or 24. Both of these have the airfoil type curved blades. Our SL4 and SL6, 4 inches and 6 inches depth with straight blades. We are working on an 8 and 10 inch. Will be released at the beginning of 2023. We have also our SL12 straight splitter blades and SL24, 24 inches in depth, straight splitter blades. If there is ever a need for calculations, please contact us. We will be glad to show you how to do this and also provide this for you. Some application and installations. Here's a dust collector at PC&D in Atlanta, Georgia. As you can see, we can provide the whole curvature apparatus along with the silencers and the stand. We actually took a dust collector that was producing at 300 yards away, still a noise level at 88, and we took it down to 45. Another picture of the dust collector. Dyer Avenue tunnel silencers, you can see that these are stacked and nested. On this specific tunnel, it was 144 inches tall and 168 inches wide, meaning this is done in multiple silencers that are nested and stacked together. You can see how everything is either crimped together or bolted together to create one big, large silencer bank. And here is another pictorial of this where the screens have been installed in front of it. And you can see the inner baffles running up and down vertically all through the screen, creating one large bank of silencers. The Citibank building exhaust silencers, again, you can see how these were stacked and nose clips were added. Apologize there. Nose clips were added. This ended up being 8 feet tall, but it ended up being 40 feet wide. You can tell it's being held up by Unistrut here. The waterfront substation in Washington, D.C. This was ultimately designed with our SL6 silencers. You can see all the different size of tubing steel that we supplied here as well. This is a door. This is a door on the right-hand side. It's closed for right now, but you can see that the silencers were bolted on the face of the tubes and made as a humongous wall and door system. On the top, we used our SL4 louvers. Oh, go back. This was a clear anodized protection, has roughly about a 25-year lifespan. And this is a green anodized on top of our SL4 louvers. And you can tell this was done in one large embankment per each area. And we supplied the steel structure here as well. Moving on to our pipe and duct lagging material. With this, it is an excellent way of wrapping not only just pipe and duct, but wrap a silencer. When doing so, the outer reinforced foil jacket, along with the mass-loaded vinyl noise barrier, along with the quilted fiberglass decoupler, gives you a great way to quell any type of breakout noise that could be happening within the duct and or within the silencer. Case in point, when you have this type of material wrapped around a silencer, I think, working on a white paper, I think it is much better than doing HTL casing silencers. Now, HTL casing silencers are 2 layers of sheetrock in between 2 layers of 18 gauge and 16 gauge. 16 gauge is outer, 18 gauge is inner steel. And this does do a very good job of quelling any type of radiated or breakout type noise. You get roughly around about 6 dB added extra, not each octave but total. The 1 inch though on the duct leg material, 1 inch is thick, gives you an SEC of 29 and gives you roughly around 6 to 7 added dB total reduction. The awesome thing about the 2 inch, it gives you somewhere around about 11 to 13. So it is better to wrap the silencer with a 2 inch thick quilted fiberglass decoupler. It is also cheaper. It is also easier to install, and is also a lot lighter in weight to install. And so this is something that we are working on a white paper on. And we will be issuing this out to the entire engineering and consulting field at Q4. Our quiet vent silencers, also known as air transfer systems or crosstalk silencers. Here you can see, for example, for the type CT, this is designed to replace the ceiling tile over movable walls or fixed partitions. You can also use type C, H, or W in a wall, in a door, or in a ceiling. Type S are vent shafts. These are excellent. A good example for this is in hotel rooms, between rooms, in order to quell any type of noise from one room to the next. So that way you don't hear your neighbor, is you apply these vent type S vent shafts, and that way air goes straight up between the walls. The military likes to use these between rooms. They also like to use the CT between rooms as well, because some of the rooms are partition type removable walls. That way, say there could be a movie being played in one room and a pilot could be going over his assessment in the other. That way the two do not hear each other and cancel each other out. Download this brochure from our website as well, because this gives you all of the nice acoustical performance criteria for noise reduction in decibels. It also gives you all the different type of models, all the different sizes, all the different static pressure drop, all the great information that you need to know. If you need to have one of these modified, please let me know. And we are also looking at producing this onto our virtual tool starting in Q1 of 2023. Now, what I would like to do is switch over to our snap tool. And what we have is a great example here of what we want to do here and apply this type of process. So we have a fan, we have 10 feet of duct, bin number 1, 20 feet of duct, bin number 2, 15 feet of duct. With our snap tool, you go here and you register for the login. I will be notified. If there's any issues, let me know, send me an email. But simply just go ahead and fill all the required information out, hit register. I will get a notification and I will approve you right away. This is a great tool to do product assessment. And when you're looking at a new project, you click on new project, fill in the proper information, hit save. I've already got one ready here for you guys. So we'll go back, select the training. When you want to add a system, you can add this system and you can say, we'll say this is a 0914 22 supply for today, and hit save. And so you can see every time you put something in, it's going to continue saving it little by little by little. You can do this either a room side calculation or atmospheric type, again, outside. For this purpose, we'll do an inside. You click on the room to set your parameters or the tree of the house. Here you see that there are defaults. We will change this to a nice size room to say 40 by 40. Typical room height is going to be around about 12 feet. Distance of listener will be 6. The grill width and height is the same as what the ductwork is. All right, so we'll change this. So for this one here, we'll use 40 by 36. You can do an NR level, you can do an NC level, or you can do a DBA level. We'll do an NC level here. And let's set this up for like a college dorm room or a nice office, quiet office space. We'll set it for 35. Click OK, and you are now set with your parameters, which is great. Now, for example here, remember our PDF here. We have the fan, all the ductwork. So what we're going to do is we're going to set this up, and the fan first. If you have the cut sheets of the fan and know all 8 octabands of those fan, whether it be inlet and or outlet, plug those in, put the fan name here. It is now 100% accurate for that piece of equipment, fan, chiller, whatever. If you do not know and have those cut sheets, but let's say you have a forward centrifugal, you've been given this parameters, you've been given a CFM, we'll put this at 10,000 CFM, and we have the fan pressure drop at 1.5. We have enough database dating back to 1970, and so it is very conservative, but we have enough database to where you can get by with this. Click and then click OK again, and now we have complete setup of how our system is going to be. This is a pass-fail. It's either red or green. You either are able to do it or not. We try to keep it simple. we are modernizing this thing, and we're taking this to again the next step where you can do a couple different systems together, because we know that's how things are being done a little bit here as well out in the field. Now remember, we have 10 foot of ductwork and a bend. So typically you do not want to put a silencer again right next to this fan. So we have a lot of ductwork here we can work with. We can come back and say we can put either duct silencer here, or we can put a silencer here, or it might need two. We don't know, but technically you do not want to put one here. And a silencer always should be at least 2 feet after a bend if you're going to do that. So before a bend and after a bend, ASHRAE and SMACNA, they suggest very, very strongly that you have at least 2 feet of ductwork before or after the bend before inserting any type of silencer. So what I'm going to do is I'm going to go ahead and put in my ductwork. You have a couple different things here you can use from. Remember, Q ducts, quiet ducts, and our bends. So today we're going to focus on these three. If you want to focus on splits, break-ins, breakouts, again, email me. We can go over those together one-on-one. For ductwork, typically it's going to be the 25 millimeter lining. Again, smallest cross section is what you're going to enter in. Meaning, again, conservative approach. We have 10 feet of duct. We then have a bend. Number of bend is 1. Smallest dimension is 36. So what we have right now is this section right here. Remember, 2 feet right after the bend. So I'm going to go ahead and insert 2 feet of duct right here. I'm going to skip right here because that's going to be, again, we're working on 20 feet. So I'm going to go ahead here and put another 2 feet of duct right before that bend number 2. I'm going to throw in bend number 2. And remember, we have 15 feet here. I'm going to throw in 2 feet of duct right after this bend. So we have our system. We have the same system right here. Sorry, I can't grab it. There we go. So what you see right here is right here so far, but we have not inserted any silencers. And what we see here is the first 2 bands are really giving us fits. So what we can do here is we can go in here and hit Q duct, leave it on quick pick, or pick a silencer. Have some fun here, folks. I like to leave it on quick pick. So remember, our width was 40, 36, and we're at 10,000 CFM. Now, Melinex, this is whether it's got polyethylene liner or not. Typically, leave it at no. Click OK. By leaving it on quick pick, it allows you to either, it might give you 1, might give you 10, could give you 20, could give you none. And then you need to go back and reassess the entire system. Here, what we're getting is none. So what I like to choose, and this is my silencer of choice, is the LFM. It is a good starting silencer to start with when selecting a silencer. It is low frequency mid-grade, meaning it's going to give you really good mid-grade octave insertion loss numbers from the 125 to the 1K. Mid-range, at the same time keeping low pressure drop. So by selecting this, it now opens up to where you can select the length. Remember, we had 20 feet to work with. I'm going to go ahead and toss in a 10-foot silencer right away. We're almost there. So now, remember, we had 20 foot here. I'm going to come back here and I'm going to say, all right, so I'm going to close this 20 foot off. So now I'm changed the 2 feet to 5 feet, change this 2 feet to 5 feet. So now we have closed this entire span off of 20 feet, right? We have basically ductwork, silencer, ductwork. Now, remember here we have 15 feet to work with. We are still, we're getting there. We're almost there. Remember we had to get to NC level 35. We're at 39. So let's go in here. We're going to put in the same type of silencer. That's important. When you're dealing with 1 silencer or 2 silencers or 3 silencers, especially 2 and 3 in sequence in a type of run, you really want to work with the same type of baffle arrangement to make sure as air flows in and out of the silencer, again, it flows proportionally and directionally. And again, that's important. If you are changing the direction of airflow from one silencer to another within a system, it could cause sonitor and self noise within the system. So here, I'm going to go ahead and throw in a duct, a sonitor right in this segment right here after this duct. We got 15 feet here at the very end. I'm going to go ahead and throw in a 3-foot sonitor for right now, a small one. Okay, we're almost there. I tell you what, we've achieved the NC value, but we haven't gotten this green yet. So I mean, it's passing. We're still 2 dB shy just in this octave band. So there could be some noise being emitted here. So what I will do then is I'm going to go in here. Sorry. I'm going to go in here and I'm going to change this 4 feet, see what happens. We're there, 0. No noise being put back in the system. Also, no loss. So this one, it wins. So what I can do is I have a 4 foot, I have 2 feet of duct, so 6 feet. I need to close this off. So I can come back in here and I can put in duct here. I can put in 9 feet. So now I have 1. So this is even better. So my total, by closing this entire system off, I have now been able to do 2 things. 1, the entire system passes. Second, I'm putting no noise back into the system. Third, I've actually been able to achieve an NC level of 28. Now let's say that they want to come back and be like, oh, well, we need to have this dB. Go back, click on the room, go back, change this from NC to dB. You're at 0 dB. You're at 32. So again, with the safety factor, it still remains the same. You have achieved a 32 dBA. You are still good to go here. If you need to populate this, you can PDF this as well. And the really cool thing is when you look at it, this is then what this looks like. So for today, I hope you've been able to take away with some of the different of our products and system analysis. Sign up for our tools, enjoy, and again, any type of questions and or comments that you have, please feel free to email me and or call me at any time. I'm here to help and assist at any given time. Thank you very much. Have yourself a great afternoon.